in Science is here with you. My name is Elena, and we're happy to welcome you to our Science Kids lecture series, a popular science space for children and for anyone beginning their journey into science. Today, I will be your lecturer, Elena Companiets, astrophysicist and education coordinator of Science Kids, and I'll try to tell you what kind of spacecraft we need in order to travel to other planets. So get comfortable. We're about to begin. You can watch this webinar thanks to the support of the University of St. Andrews in Scotland, and now is the perfect moment to send some likes or hearts in the chat and share your thanks for supporting our lecture series. If you're watching the recording on YouTube, make sure to subscribe to our channel, give this video a like, and thank the University of St. Andrews in the comments. And while you're doing that, let me introduce myself once again. It's me, Elena. You usually see me here as the host of our webinars, but today I'm your lecturer because I work at the main astronomical observatory of the National Academy of Sciences of Ukraine as a junior research fellow, so I hope I'll manage to tell you something truly interesting about spacecraft. First, I have a question for you. Would you like to travel across the galaxy? If yes, type A+ in the chat. If no, type a minus. And if you're watching us on YouTube, write your answer in the comments as well. I'm very curious whether you dream of space travel. When I was much younger, before school and later in school, I dreamed of flying to other stars and seeing what everything looks like out there. And judging by the activity in the chat, many of you dream about it too, although some have watched certain movies and now really don't want to go. Well, let's figure everything out together. As we often do this season, we'll begin with science fiction because it's not just you or me. Generations before us and generations after us have dream, and will dream about traveling through space, exploring our galaxy, or even leaving it altogether. And here I want to show you, compared to an ordinary football ball, how spacecraft were imagined in different works of science fiction. Here you can spot The Martian, Star Wars, and many others. Some ships you may recognize, others may be completely new to you. Right now, the specific names aren't important. What matters is how wonderfully strange these fictional spacecraft can be, from tiny ones to absolutely enormous ones. This video is 18 minutes long, and even at high speed, just imagine how much human imagination has created and described. And if we skip toward the end, you'll see the biggest spacecraft ever imagined, and some even larger than whole planets. Of course, our technology isn't anywhere near this yet, but let's look at what we can do. Because we've already been to the moon. Science fiction like Star Trek, Lilo and Stitch, and many others let us imagine how aliens or future humans might travel through the galaxy. But where is our technology right now? Let me begin with a short story. Once upon a time, humans looked at the stars and wondered if we could ever reach them. Today we're already flying to Mars, not humans, but robots. Still, we have the technology to send those robots there. More than that, spacecraft launched decades ago, like Voyager and New Horizons, are already nearing the boundary of the heliosphere. They are now more than 100 times farther from the sun than Earth is. It will take them much longer to reach the true edge of the solar system, but their current distances are already incredible. It was chemical engines that allowed Apollo 11 to reach the moon, and chemical engines that carried the James Webb Space Telescope into its orbit. Almost everything in modern astronautics has been achieved thanks to chemical propulsion. You can see one of these engines here. They come in many sizes and designs. Today, we won't go deep into how each one works. Each engine deserves its own lecture. Instead, I want to tell you where everything began, what we have now, and what might come next. A true breakthrough was the Saturn V rocket. It was Saturn V that, in 1969, I hope I didn't mix up the date, delivered humans to the moon for the very first time. Just imagine, a human stepped onto another celestial body. Saturn V made this possible. On the slide, you can see the rocket launching, and below, one of its stages with its chemical engines. When I visited NASA, I saw a full-scale model of Saturn V, and photos truly cannot convey how enormous it is. Standing next to one of the engines, the part from the rim to the midpoint alone was my height. That rocket was built over 50 years ago, and since then, technology has advanced enormously. So what do we have today? In the last 10 years, humanity achieved another major breakthrough, one that made access to space much cheaper. Getting to space is extremely expensive, But once SpaceX succeeded in creating reusable rocket stages, the boosters that detach and return to Earth, spaceflight changed dramatically. Here you can see the booster landing back on the launch pad. Thanks to reusability, prices dropped significantly. It used to cost around $10,000 to send just 1 kilogram into orbit. Now, with Falcon 9, it can be less than $2,000. Today, another major spacecraft is being developed and tested, sometimes successfully, sometimes not. The Starship spacecraft and its super heavy booster. NASA and SpaceX plan for Starship to be the ship that takes humans to the moon and, eventually, to Mars. Here you see a simulation of how a Starship mission to Mars might look. The booster returns to Earth, while Starship heads toward Mars, but Starship still uses chemical engines, meaning it needs an enormous amount of fuel. So first Starship must be launched into orbit, then a full tanker of fuel, and only after refueling in orbit can it head toward Mars. And here's the important part. Everyone on board will be flying one way. There will be enough fuel only to reach Mars, not return. The good news is that Mars has the resources to produce fuel, but factories must be built first. Robots may need to go before humans to construct them. Another complication is cosmic radiation, but we'll talk about that in the next lecture with a radiobiologist joining us from Japan. So the ship likely to take humans to Mars will be Starship. Let's move on. As I mentioned, chemical engines burn fuel like a candle and release the energy needed to push a spacecraft forward. But the huge downside is that they need massive amounts of fuel. With chemical propulsion alone, we can't travel much farther than the moon or Mars. And even Mars is a one-way trip unless fuel can be produced there. So, does humanity have alternatives? Yes, and that's the good news. Some alternatives are already in development. One of them is nuclear propulsion. There are no working nuclear engines yet, but NASA is developing them. Here you see Project Draco. Nuclear engines work differently and could allow spacecraft to accelerate faster using different types of fuel. They could shorten travel times to the outer planets, perhaps to decades instead of centuries. Yes, decades still sound long, but for spacecraft, that's progress. Such engines would allow us to visit Jupiter and return within one mission, build orbital stations between planets, and even send next-generation interstellar probes, small, unmanned spacecraft. So chemical engines open space for us, but nuclear engines might make it reachable. There are also other theoretical propulsion technologies that could accelerate small probes to extreme speeds, but today let's focus on human travel. Even with nuclear engines, we still won't reach the nearest star within a human lifetime, not in 50 or 60 years. Proxima Centauri, our nearest star, is over 4 light years away. If you could travel at the speed of light, 300,000 kilometers per second, it would take 4 years. But the fastest spacecraft humans ever built reached about 100 kilometers per second and carried no humans. At that speed, Starship would take around 60,000 years to reach the nearest star. A nuclear engine might shorten that to 25,000 years, still far too long. But here's the good news. We still don't know everything about the universe. We don't really know what dark energy or dark matter are. So maybe something we discover later will open new possibilities. This means we shouldn't dismiss theoretical concepts, those that are mathematically possible but not yet achievable. Many of these concepts appear in science fiction, and in some are surprisingly realistic. One of my favorite examples is the warp engine, like in Star Trek. Warp engines appear in almost every film or book about galactic travel. And here's the exciting part. Warp engines are theoretically possible. Let's briefly explore why. Warp drives rely on creating a wave in space-time. Imagine a boat on water. The wave pushes the boat forward. Now imagine that space itself can also carry waves, and it can. These are gravitational waves detected for the first time in 2015. If a spacecraft could create such a wave, it could ride it. The wave moves at the speed of light, so the ship wouldn't break any physical law because the space around it would be moving. This would allow reaching the nearest star not in 25,000 years, but in 4 years. But to generate such a wave, we would need exotic matter, something with negative mass. No such matter has been found yet. Still, perhaps one of you will become a physicist and discover it. Another theoretical possibility is the wormhole, shown in Interstellar, where Nobel laureate Kip Thorne served as scientific advisor. A wormhole is like folding a sheet of paper so that two distant points touch. You move instantly from one to the other. The physics allows it, but we've never observed a real wormhole. Why? So today, humanity has far more technology than it had 50 to 60 years ago, and who knows what we'll have in another 5, 10, or 20 years, or what you might create if you choose this path. I hope these ideas inspire you just as they inspire me. And since dreaming helps us stay hopeful and curious, especially on gray days or when the power goes out, we've prepared some science fiction reading recommendations for you. The first book is Ender's Game by Orson Scott Card, recommended for ages 12 plus. It takes place in the distant future after Earth has survived a terrible war with insect-like aliens. The main character trains in an elite battle school, going through complex simulations to prepare for the next conflict. If you don't like bugs, maybe skip this one, otherwise it's fascinating. A more cheerful option is Sapiens by Volodymyr Arenev for ages 7 plus. The story follows two schoolboys in Kiev in the year 2178. Kids fly to school with jetpacks and can enroll in Star Pilot School. Honestly, I'm a little jealous. I've dreamed of such a jetpack since childhood. Write a plus if you've dreamed about that too. Another recommendation is Victor Robot, the Planet Collector's Diary. Victor Robot, the chief mechanic of the artificial star Zoriana, travels to Earth to visit a girl named Vika, granddaughter of the star's creator. Together, they explore her grandfather's diary and embark on cosmic adventures filled with astrophysics and imagination. There is also a wonderful animated film, Victor Robot, highly recommended. And here's something else, the animated series Star Trek, Prodigy, recommended for ages 12 plus. A group of teenagers discovers an abandoned starship and tries to explore distant galaxies, but the ship is damaged and a villain is hunting them. They must unite to protect each other and their newfound ship. I hope these stories inspire you as much as they inspire us. And now we move on to the next chapter of your cosmic travel diary. This time, the chapter is called Spacecraft. In this section, describe or draw, using any method you like, what your character's spacecraft looks like, what makes it unique, and what tasty treats your character keeps on board. We'll share the template in our Telegram channel, or you can draw it by hand. Send your completed tasks to our Telegram chat. We can't wait to see them. Marinain, that's all from me for today. Our next webinar will be led by Daria Zaremba, and together we'll talk about how much it would cost to colonize Mars. We look forward to seeing you at the next session, and don't forget to like this video and subscribe to our channel. Bye-bye. See you soon.